G'day everyone, my name is Benjamin Rudolf and this is my submission for the AENG201 Task 4 final submission. Now, the project brief. The project site is a 1.34 hectare site located at the northeast corner of the Innovation Campus. The purpose of this site is to be subdivided into smaller housing developments that house zero net carbon energy houses. The desired occupant for these houses is two professional sharers aged 18 to 25. It is assumed that these individuals work part-time jobs while studying full-time at the University of Wollongong. As you can see here, the design has gone through many iterations since first conceptualization. From a bubble diagram to preliminary designs to a final floor plan. The final design floor plan looks something like this. It is quite simplistic in design, but I think that would ease construction rather than hinder it. The main focus of this design is passive house energy reduction. We will go through this a bit later. As you can see, it has two large bedrooms, an open plan kitchen and living room, and a laundry and bathroom. The house complies with the low-rise housing diversity code. Now this is a final design master plan, which shows the encompassing block of 20 meters by 25 meters. As can be seen here, along with the house, there is a 3 by 12 dimension back deck with an 8 by 4 garage and a lot of yard space that can be used to the occupant's desires. It is also noted that we've installed a verge garden on this house that we hopefully will bring some light into the community. As you can see on the right hand side, that's the subdivided site, which will have a total of 18 different houses developed on it, along with a small community area at the northern end of the site. These are the elevation and section views of the house. The section view is taken looking at an easterly direction. Now these are the two in-depth construction details of the roof and walls. As you can see here, the walls have a brick exterior that will be used for thermal mass and use Bradford insulation with a hempcrete cement layer on the interior to hold it all together. The roof is quite similar, except the exterior is made out of Tesla solar roof tiles, which will hopefully collect a lot of electricity for our house. As you can see here, here's a depiction of a 1:50 scale 3D model of the house made out of cardboard. As you can see here, the roof was quite complex and collapsed a little bit, but I think it is a good way to visualize physically the house. Now, the net zero energy design plan. The main focus of this design plan is passive house energy reduction. It's the easiest way to save energy is if you don't need to use it at all. The main way this will be accomplished is by using polished concrete floors and brickwork on the outside as thermal mass, which will heat the home which will collect energy and heat during the day and emit it at night when it is cooler. The back deck and several of the structural components of the house will be made out of recycled wood, which is a good way to embody carbon into the home. Blackout blinds will be used, so on hotter days, it'll stop sunlight from entering the home and it will cool it better. The hot water pipes of the home will be installed in the roof underneath the solar panels. This will passively heat the hot water with needing little from the solar hot water heater. The double glazed windows will prevent a great amount of leakage of air, and it is highly recommended that all electrical appliances installed must have a minimum 4-star energy rating. Now, the energy generation methods. This will be accomplished by the energy will be generated by the installation of Tesla solar roof tiles on the garage and the main house, as well as the installation of 2 Tesla Powerwall batteries on the western side of the house and the eastern side of the interior of the garage. The average, according to Osgrid 2020, the average consumption per person is 13.7 kilowatt hours per day. With 2 people, this is 27.4 kilowatt hours per day. With 134 meters square roof area, even on a cloudy day, this target will be reached. With each Tesla Powerwall is able to store 13.5 kilowatt hours of electricity So with 2 of them, we can store a full day's worth of electricity. So even during a tornado, we will still have power. This will be supplemented by a housing management system, which will streamline and make the house more energy efficient. Thank you for watching my video. I'm very excited for Thursday when I get to have a Q&A with you. Bye.